This oral presentation is going to be talking about the natural phenomenon of ocean waves hitting barriers. But firstly, how do waves work and how are they formed? The most common way waves are naturally formed is called wind-driven. The name gives away how it works. The wind blows across the water, causing friction and giving the water energy. From this, it is known that the more wind there is, the larger the waves will be. For example, a light breeze will cause less waves than a hurricane. Another factor that affects the size of waves and the speed is something called the fetch, which is shown in this diagram in the middle. The fetch is basically the area where the water is, so a large ocean will have a larger fetch than a small lake, meaning the wind has more time and space to create larger, stronger waves. Now, as the water gets continual disturbance, e.g. the wind hits it for longer periods of time, it creates a wave crest, which is the beginning of the wave. From here, the wave starts to form a sine wave pattern as it moves across the water. This is because the water molecules are going in a circular motion as shown by this illustration on both the left and the right. Ocean waves that act like this are called orbital progressive waves because of the orbital path of the water molecules in the water going in a circular fashion. Now that some background information has been given about how ocean waves are created, it can be explored how waves are affected by different barriers. As a general whole, the most common man-made ways to stop water or limit the way it is affected on the Earth is breakwaters. Breakwaters can come in many different ways, and some of them are like this picture here, where they're walls, where it just acts kind of like a slit experiment where it only lets some of the water waves go through. Another way are these tetrapods on the left here up the top. They line beaches that have been placed out, and the way they are shaped makes it that when waves hit it, the water is rushed around it and not through it, so it stops the water getting to the coastline easier. Another way is just general walls in the water, like on the picture on the right, and this just stops the waves from crashing into the shore and stopping erosion and such like that. But another thing we can talk about is reflection, refraction, and diffraction of waves. So with reflection, breakwaters are used like the wall one for reflection because the water hits it and the water is reflected back. This is like the seawalls. In this case, the wave retains as much of its energy and then bounces back towards open water. Another way is diffraction, which is like those walls shown in the first picture of the breakwaters. And this shifts the energy within a wave, allowing a new wave pattern to form that is not as strong as the current waves that are going through the slit beforehand. And then finally, there is diffraction, and this can be used by the walls placed in the water as well that bend the waves around. This is shown by the picture in the middle. As it's hitting a shoreline, we can see that the waves start to bend, so it goes more from, instead of left to right, it goes more of a horizontal inwards towards the shore because it is bending through refraction.